Okay, what I have here on the bench is a an antenna amplifier splitter made by Hills, and just not long ago there was a big lightning strike around my place, and the amplifier stopped working. So obviously something is being damaged. So I decided to take it apart. This is one of these. It's got a modulator RF in, and which actually can handle remote control IR signals, as it says there. IR out as well. It's got antenna RF in, and then it's got auxiliary RF in. Now, and then it's got 6 outputs. Split there. I've tested the auxiliary RF in, and that works. So that's the circuit board, and this is just a mix, gain, minimum, middle, maximum. It's just attenuation with some resistors that they did on the switch. Anyway, get a bit of a closer look. I'm only filming with a Samsung phone here, so that's a 5-volt regulator there, filter capacitor, bypass capacitor. It's got a protection reverse diode here, and this IC looks like it handles the IR signal. So, and by the way, the IR input is on this jack here, the infrared for the remote controls. Anyway, I've tested the auxiliary RF in, which is this one, and it goes through that capacitor there and a resistor, and then it goes to, let's see where I can see it, if I can see it, this small transistor here, and so it's got the same thing on here, which is the main antenna in. This is just a protection diode here, which obviously didn't really help, because I found to be this transistor here, a 4-legged one, is damaged. So let's see. So we're talking about, where's the, okay, we're talking about this part here. So the input comes in here through the capacitor, and it goes to the first pin there, which would be the base, and then it gets a little bit of amplification through the other side. Now, what I did do is, I think, because I don't have the circuit right in front of me here. Well, I don't have a circuit diagram for this. I just had a look, had to find this what this part was. At first, I didn't know what it was. So we'll not be able to see with this. So I'll just pause this. Anyway, just to recap a bit here, let's see if we can see the part. It's still no good. So even under the lens, there's no way, I don't have enough magnification Well, maybe you see something like that. I don't know if you could see, but the number on the part is AMS. AM and a small s. So anyway, so what I did originally, I put a signal here, and I realized it was not going past this pin here on the transistor, which I found it's a transistor. And then I put a signal on the auxiliary, and I could see that the signal did pass through the transistor here on its collector. Sorry, on the emitter. But anyway, so now you can see there AMS. What I had to do some research to find out what that part was, and the way I did it is I went on the internet and I found this PDF file here called SMD codebook. Without this, I could not find what the transistor was. Anyway, so there's some other sources on the internet as well you could find. And if I go down here, the list of different... well, the first thing that I had to find out is what type of package that part was. And I'll show you. So I had a look at a few different components. And here I've highlighted it. So I had to find out what type of package, and that package was a SOT 343. So that's the beginning of my search, okay, to find out what that part was. So when I had to look at surface mount components, I found that that package was a SOT 343 there. And then of course the number on the component was AMS. And here this reference book on a PDF file says it should be a BFP 420. NPN 25 gigahertz, 4.5 volts, 35 milliamp transistor. So then I looked up that part, and it's made by Infineon, and of course everything matches, starting by the shape of it. Pin number 1, which is the base, and then 2 is a wider terminal, which was an indication of the part, the SOT, what did I say it was? 343, which is here. I'll decrease the size here. So in here it tells us it's a high gain, low noise amplifier for oscillators up to 10 gigahertz, and RF line there, 25 gigahertz. Anyway, without going to all the technical stuff, so that's the sort of part inside. Anyway, when I did my testing, I found that I had a leak between base and emitter, and compared with the other transistor, I could see a difference. So let's see if I can show you that. Okay, so here I've got a multimeter, on Ohm's law times 1. Okay, so I'm gonna test the base and the emitter. Okay, so if I put the positive terminal on the base, okay, and it's hard to hold the phone and okay, positive terminal on the base and the negative on the emitter, you should get high resistance. Well, there I'll show you what the measurement is. So the resistance is around 250 ohms, which should be much higher than that. Okay, you should be infinity. So on the comparison on the other transistor, okay, it will show that, there you go, it's on the infinity side. So the negative on the base to the emitter, you should get some resistance, but when you swap the leads around and put the positive on the base, you should get infinity. So that's showing that the transistor is leaking. Okay, so the lightning strike have damaged that part. And what I said before, the output will be on the collector. Okay, so I did get a couple of parts for it from Farnell. You can actually get them from China as well, very cheap. But for the sake of not waiting too long, which I still had to wait a long time, even from Farnell or Element 14, and that's the part number there. Okay. And that's the couple of parts there. Can't focus anyway. That's the new parts. So I'm just going to film here, just removing the part, and so with the hot air gun, I'm going to remove the part, and hopefully we'll fit a new one. So just warm this up. There you go. So that's the part off. This thing can't focus, as I could see. So that's the part. There you go. So now I'll just clean up a bit the board here. Focus, you bastard. Okay, doesn't lock the focus, this camera here. Focus on my hand. So there, I removed the part. As you can see, it's not there anymore. There's the four contacts there. Okay, and I'll just clean a bit of the solder here, and then I'll put the part in and resolder it. Bit of alcohol here. soldering the wrong pad. Okay, soldered. Anyway, let's see what we can see here. That's the new pad, soldered in place. And that should be the end of it. So I will test it out and see what we get. Okay, so now I have set up, and this thing doesn't want to focus, a signal generator here. So I've got that set to 18 megahertz sine wave on the input. Okay, and on the output I've got the oscilloscope there, and I am measuring the 18, switch that off, the 18 megahertz. And we can see that. Okay, so if I disconnect the input, okay, the signal goes away, connect the input back up, and there you go. Now of course I didn't film before when they had the faulty transistor, but I had nothing, okay, on the output. So now I've replaced the transistor, and it's working, and I've got a signal out. Anyway, the best way to test this is on the hooking up the antenna back on, and your TV, the output to the TV antenna, which I already tested that, and it's working fine. So anyway, so that's the end of the testing here, and the model number of that Hills product, well, that's a serial number. I'm not sure exactly of the model, but for anybody ever want to come across this, it looks like this with 6 outputs. So yep, I fixed up the RF amplifier. Okay, thank you.